Okay, so what we've got going on here is a 3 by 3 system, 3 equations, and 3 unknowns. And let's see what happens when we go ahead and do it. Again, first of all, the first step is to get a 1 in the leftmost non-zero column. All the columns are non-zero, so we want a 1 in the upper left. And again, there are two ways to do this. We could divide by the first entry of the top row, or this time we're going to swap rows 1 and 3 because row 3 has a 1 uh, at the beginning. So when we do that, this is the matrix that we come up with. All right. And thus. And we draw the notation. Okay. Okay. Great. Done. And what's the second thing we want to do? We want to make sure that below this 1 that we just put at the top has zeros below it, because that's what reduced form says. So again, we see a 4 in the second row, so we add -4 times the first row to the second row to get rid of that 4 and turn it into a 0. And we're going to take -5 times the first row, add that to the third row to give us a 0 where there used to be a 5. Now again, I encourage you to do the arithmetic here yourself, but excuse me, I'm, just speeding my way through it. Okay, so what is the next step for us to do? Once I'm done drawing this box, we will find out. Okay, once I've got the 1s and the 0s there on the left, I can ignore the first row and I will look for the first non-zero column right there, not the other one, and what's left, which is this 1313 column, and I want to get a 1 in the top row. You might notice now that you can actually do something a little bit slick to you don't even really have to follow the algorithm to finish this up, but let's just keep doing the algorithm. So we're going to divide row 2 by the first non-zero entry, which is 13, and I tried to make the numbers work out pretty nicely this time. Again, that's the sort of thing I'll do in an exam. I'm not going to make you deal with fractions and decimals and, whatever. I'm just going to have you, deal with things where the numbers are, fairly reasonable. Whole numbers. I want you to focus on the process and not the arithmetic. Okay, I'm erasing stuff. And what do I write next? Well, I just put a 1 in this at the beginning of the second row. For this to be reduced, I need zeros above and below that 1. I need a 0 here and a 0 here, so that I have a leading 1 with zeros above it and below it. So to accomplish that, I'm going to add, what am I doing here? So we're going to add, since I've got a -3 upstairs, I'm going to add 3 times row 2 to row 1. Okay, hiccuping again. And since I've got a 13 downstairs, I'm going to take -13 times row 2 and add that to row 1. Uh-oh, I made a mistake. That should be row 3. Anyways, let's keep going. This is what I end up getting. And we get 3 zeros in the bottom and then a -4. Huh. Notice that the -4 is to the right of the bar and all of the zeros are to the left. Well, whenever we reach this sort of circumstance, we can always just finish up our problem because we're just looking to solve the system. We don't necessarily have to get this completely down to reduced form. If you want to, it's a good exercise for you to sit down and actually complete the reduction process and actually, the elimination process and get this down to reduced form. But anyways, so as I'm saying here, a row with zeros left of the line or the bar and a non-zero number to the right of the bar implies no solutions. Why? It's supposed to be an N. This case implies, so this specific case, the bottom row means that 0 is equal to negative 4. 0 is not equal to negative 4. That's false. So that's the problem. Okay, erase that. So note that we didn't, I think I already said this, but actually finish the putting this from the matrix into reduced form. We can keep going, or we can just stop, because what we saw the bottom row look like. We can stop whenever we see a row that looks kind of like the bottom row. What sort of row is that? A row that has a bunch of zeros. Let's pretend 7 zeros, and then just some number m, where m is not going to be 0. And all of these dots above the m and the zeros just imply that the row could be anywhere in the matrix. It doesn't just have to be at the bottom, it could be anywhere. Sometimes you might end up with that just in the middle. So as an exercise, I would like you to actually finish the the elimination process. So finish putting the matrix that we had into reduced form. Okay.